Today we're studying a review of basic integration rules. This is a review of all the rules that we studied in the AB part of the course. Just continuing on before we get into some more advanced integration techniques. You've already studied these. Sometimes the difficult part of integration is that slight differences, in your integrand will lead to really, really different solutions. Okay. The first thing we're going to be reviewing is using long division before integrating. And you can see down at the bottom, you use this if a rational function has a numerator of degree greater than or equal to that of the denominator. In this case, we clearly do. Degree of the numerator is 2, degree of the denominator is 2. And so we're going to set up a long division process. X squared plus 0x plus 1 goes into x squared plus x plus 1. Ask yourself, how many times does x squared go into x squared? It goes into it one time. Multiply now, x squared plus 0x plus 1. And don't forget, we are going to be subtracting each of these. So I'm just going to change the signs. That reduces there. X minus 0x is x. 1 minus 1 is 0. And so our solution here, okay, can be rewritten as the integral of 1 plus x over x squared plus 1 dx. And we like this a lot. We're going to rewrite this integral to be the integral of x dx, the integral of 1 dx, getting ahead of myself, from right here, and then plus the integral of x over x squared plus 1 dx. This is super duper easy. We know what that is over here. This sets up very, very nicely for us for a u substitution. We're going to let u be x squared plus 1. Du then is 2x dx. We don't quite have that. We have x dx, so we're just going to rewrite this as a 2 here and a 1/2 there. I have not changed the value of my integral. And we're going to rewrite our problem as the integral of 1 dx plus 1/2 the integral of, here's my u, 2x dx, or my du rather, and my u is down here, x squared plus 1. And so the integral of 1 dx is x plus 1/2 the integral of 1 over u du is going to be the natural log of the absolute value of u. And now I'm going to resubstitute my u. Don't forget our plus c. So this is x plus the half the natural log. I don't need the absolute value anymore because x squared plus 1 is always positive. And then we have plus c. So again, we're using this when the degree of the numerator is greater than or equal to the degree of the denominator. Next one we're reviewing is a change of variables. Down here we have x plus 1 squared in the denominator, 2x in the numerator. You could take your 2 out to begin with if you wanted to. I'm going to leave it in there for right now. I'm going to go ahead and let u equal x plus 1, which makes du dx. And that's great. We have a dx here, but we still have that 2x in the numerator. So I'm going to rewrite u equals x plus 1 to say x equals u minus 1. And now I'll be good to go. We'll rewrite this integral as the integral of 2 in parentheses x was my u minus 1. Dx is du. And it's going to be all over x plus 1 was u squared. Now we're just going to do a little simplifying. This will be the integral. We're going to distribute here 2u over u squared minus the integral, whoops, forgot my du. Don't forget that. Minus the integral of 2 over u squared du. And now we're just going to simplify this integrand. Integral of 2 du over u minus 2 and this is u squared to the negative second du. Ready to integrate? This becomes 2 the natural log of the absolute value of u minus 2, add 1 and divide. So we're going to add 1 to negative 2, that's negative 1, divide by negative 1, that makes this positive, and it's u to the negative first, and then we have plus c. So resubstitute our u's now. 2 times the natural log. I do need my absolute value because x plus 1 is not always positive, plus 2 over u to the first power, x plus 1, and then we have plus c. Using two basic rules to solve a single integrand, we have the integral of x plus 3 over 4 minus x squared dx. I kind of like it if we could let u equal 4 minus x squared because we have an x up there, but this plus 3 is a little troubling, so we're going to split this integrand up into the integral of x over the square root of 4 minus x squared dx. I like this because this is an easy u substitution problem. And then we're going to have plus 3 times the integral of 1 over the square root of 4 minus x squared dx. I also like this here because that's going to give us an arc sine. We're going to let u equal 4 minus x squared in this case, so that du is negative 2x dx. I don't have that right now. Okay, all I have is an x dx, so I'll rewrite up here, negative 2, negative 1/2. And so this is going to be rewritten as the negative 1/2, the integral of, this is my du, right here, negative 2x dx is my du. And then I'm going to go ahead and bring the square root of u into the numerator as u to the negative 1/2. And then we still have our plus 3 integral 1 over 4 minus x squared dx. Okay, here we're going to add 1. Negative 1/2 plus 1 is 1/2, and divide. Dividing this by half is the same as multiplying by 2. So we're going to have negative 1 u to the positive 1/2 plus 3. This again, there's my square root, is the arc sine of x over, in this case, 2, because this is 2 squared, and then we have plus c. Just resubstitute the u now, which was 4 minus x squared. This is negative 1 times 4 minus x squared to the 1/2 plus 3 times the arc sine of x over 2 plus c.